So we are continuing from where we stopped. So this is the speed of miscomfort. Okay, so that is how we can calculate the speed of a body. All right. So now you discovered that in when we're talking about speed and velocity, we said that speed is a scalar quantity and velocity is a vector quantity. All right. Now when we talk about speed, we make use of the word distance to describe speed, that's distance over time. Now, distance is also a scalar quantity, but when we talk about velocity, we make use of the word displacement. Okay, displacement is a vector quantity. All right, so that will be all for speed and velocity. Now, let's look at acceleration. Acceleration. All right. Now, when we say that the body is undergoing acceleration, we're saying that the body is either increasing its velocity with time or reducing its velocity with time. So acceleration, we could define acceleration as the rate of change of velocity with time. So acceleration is either an increase in velocity or a decrease in velocity with time. All right. So if we must have acceleration, there must be there must be an initial velocity. There must be conditions for acceleration. Actually, conditions for acceleration. So if we must have acceleration, there must be initial velocity, which we can call u, and then we'll have a final velocity which we can call v, and we'll also have the time change, which we can call t. So acceleration is simply going to be the final velocity minus the initial velocity over time. So using symbols, we have that a will be equal to v minus u over t. So this is the mathematical representation for acceleration. Is that okay? All right, so if we take an example, let's take an example. Let's say a train moves with an initial velocity of 50 meters per second. This velocity increases to 80 meters per second in 10 seconds. what is the acceleration of the train? Okay, so a train moves with an initial velocity of 50 meters per second, full stop. This velocity increases to 80 meters per second in 10 seconds. What is the acceleration of the train? So we know that acceleration is final velocity minus initial velocity over time. So that will be, our acceleration is unknown. From the question, the initial velocity, which is u, is 50 meters per second. Then it increases to this, so this will become the final velocity, which is v. So final velocity becomes 80 meters per second, and then the time for this change in velocity is 10 seconds. 10 seconds. So put down our formula, v minus u over t. So v is 80 minus u is 50 over t, which is 10. So we have 80 minus 50, that will give us 30 over 10, and that will be 3 meters per second squared. Now the unit for acceleration is meters per second squared. You must know this and commit this to memory. Meter per second squared, because acceleration is the change in velocity with time, and velocity is also, remember we said velocity is a meter per second. So if we have that as velocity, meter per second